Welcome to The Explainer. Today, we're diving into one of the biggest leaps forward in JavaScript, how we handle things that don't happen right away. We're going to tell the story of how we escaped a really common coding nightmare to find a much cleaner way to write our code.
So, if you're a developer, you know this feeling. You're writing code, everything's going fine, and then you look at your screen and you're staring at this sideways triangle of brackets and parentheses. It's messy, it's confusing, and it's the classic sign you've fallen into what we all call callback hell. But hey, before we can really appreciate the escape plan, we have to understand the prison, right? And that problem is baked right into the way JavaScript works. It's what we call the asynchronous challenge. So what does asynchronous even mean? Well, think of it this way. JavaScript is busy. It doesn't like to wait around. When it hits a long task, like fetching data from a server, it won't just freeze and wait. Instead, it kicks off the task and says, all right, you go do that and just, let me know when you're done. And then it moves on to the next thing. The perfect real-world example is ordering coffee. You don't stand at the counter and stare at the barista for 5 minutes. Nope. You order, they hand you one of those little vibrating buzzers. That's your placeholder, and you're free. You can go find a table, check your phone, whatever. When the buzzer finally goes off, your coffee's ready. That buzzer is everything. It's the signal that your operation is finished.
Okay, so how did developers in the early days handle this? How did they deal with that buzzer vibration in code? Well, they used a pretty straightforward tool called the simple callback. A callback is, well, it's exactly what it sounds like. It's a function you hand over to another function, basically saying, hey, when you're done with your thing, could you please call this function back for me and bring the results? It's a pretty logical first attempt for sure. And when it's just one thing, it looks great, super clean. We're calling fetch data, and we're giving it a little function to run later. We're just telling it, once you have the data, just run this function with it. Simple, right? But what happens when one task has to wait for another one to finish, and then another one after that?
And this is where our story takes a bit of a dark turn. What starts out as a simple, elegant little pattern can very quickly morph into a monster we call the Pyramid of Doom.
See, the problem isn't the callback itself. It's what happens when you need things to happen in order. First, you fetch some data, then you need to process that data, and then you need to save that result. Each one of those steps needs its own callback, nested deep inside the one before it.
And this nesting is what creates all the pain. The code gets impossible to read as it just marches further and further to the right of your screen. Trying to figure out where a bug is coming from? Good luck. And error handling becomes a total nightmare because you have to manage it at every single level. It just doesn't work for complex applications.
But don't worry. From the rubble of that pyramid, a hero rises to bring sanity back to our code. Let's all give a warm welcome to JavaScript promises.
A promise is basically a much smarter coffee shop buzzer. It's an object that represents a future value. It's a promise, a contract from your code that says, I swear, I will get back to you with a value eventually. It'll either be the thing you wanted or a good reason why I couldn't get it.
So a promise really just has two main outcomes. It can be resolved, which means, hooray, it worked! Or it can be rejected, which means, oops, something went wrong. And we handle these with two different tools. You use .then for all the good stuff, the successful results, and you use .catch for any failures. This separation is what makes them so incredibly powerful.
And this brings us to the real aha moment. This is how promises absolutely demolish the pyramid problem. It's all about the power of chaining.
And wow, just look at this. This slide says it all. On the left, there's our old friend, the messy pyramid. But on the right, look at that. It's the exact same logic, but it's flat. It's readable. It reads like a set of instructions. Fetch the data, then process it, then save it. And best of all, if any one of those steps fails, the whole thing just drops down to that one single catch block at the end. It is a complete and total game changer.
The magic here is that whatever you return from one .then block automatically gets passed as the input to the next .then in the chain. This gives you this clean, vertical flow of data that is just so much easier to follow and to think about.
So let's just recap the knockout victory here. Why are promises so much better than the old way of doing things?
Well, number one, obviously, they save us from that pyramid of doom.
The syntax is way cleaner, way more intuitive. Your error handling gets so much simpler with one catch-all to rule them all. And maybe most importantly, promises became the building block for an even slicker way to write async code, something called async/await. At the end of the day, it really just boils down to this. Promises made a huge difference in how we write asynchronous JavaScript. They give us code that's easier to read, easier to fix, and just easier to think about, which makes our jobs a whole lot better.
And that leads to one last question. We went from callback hell to this beautiful, structured promise heaven. But what if? What if there was another step? What if we could make all this asynchronous code look almost exactly like simple, old-fashioned synchronous code? Well, that sounds like a story for another explainer. Thanks for watching.